In this video, we'll see how we can perform analysis or we can do predictions on unsupervised learning. So what is actually unsupervised learning? In the unsupervised learning, we are not aware of our independent variables or the target variables. We do the classification based on the characteristics of the variables. So for our case, we have this RH flower in which we need to predict what type of flower it is based on the characteristics or the qualities of the flower. So the qualities of the RH flower, or I can say dimensions, looks like this. It has a petal width, petal length, sepal width and sepal length. The iris flower is being classified into three categories, that is Iris centosa, Iris versicolor and Iris virginica. So we have this flower and we are going to do predictions based on what type of flower it will be. What we'll be doing is that we'll be forming different groups and segregating the flower accordingly. So this is what data set I have. This is the raw data set I have in this, what I'll be using actually in this video, and we'll be doing analysis or you can say predictions based on this, and we'll be forming groups accordingly. Here you can see I have around 1 2 3 4 5 or 6 different columns. One I have ID column also. So let's get into the coding and let's open our Jupyter notebook for the same. So here is my Jupyter notebook. What we'll be doing is that we'll be using k-means clustering for this. So what is actually k-means clustering? K-means clustering is a technique for unsupervised learning where we are not aware of our independent variables and, as I told you, the target variables as well. So the predictions are done basically on the features. What we'll be doing is that we'll be trying to create different clusters and combine these values accordingly. So I have imported different libraries for the same. Pandas for my data cleaning, matplotlib and seaborn for my data visualization, k-means for creating clusters. So here is my data set, as I told you before as well. This is my data set. I have imported the file in my Python programming, and this is my file, as you can see as well. So next, what we have over here is, you can see I have various columns or you can say attributes, that is sepal length, sepal width, petal length and petal width, and this is my class of my flower. So first of all, talking about the basic metadata of this data set, all are the non-null values. Four of them are float values and one of this is string value. So this is just a pictorial representation that total are 50 in number, and these are the three various classification. Now what is an elbow method? Let's get into some theory first of all. So elbow method is actually this. It is a pictorial representation where we need to find the exact number of clusters. So how we can find is that we'll take all the elements or the data numbers together, we'll square it up, okay, and greater the square, the least we can get is that the least the clusters. As the the errors keep on reducing, the clusters become more smooth, and we get to get the accurate number of cluster, we need to get this joint. As we can see, this joint is getting formed at number 3. So the accurate number of clusters, for this is just an example I'm just telling you. So the accurate number of clusters over here shown is as 3, this joint. So we'll do the same actually. Let's get back here. So as I was telling you, we'll go with this sum of squared errors. I took a variable named as k range, okay, and I took a range from 1 to 10. That means I'm going from 1 to 9 because it's 1 to n minus 1 actually. So I took another variable SSE, that is sum of squared error, and I created an open list. I'll create a for loop in this, okay. Now with the help of fit method, what I'll do is that I'll put all the independent variables, the numerical variables, I would say, sepal length, sepal width, petal length and petal width, okay. This append function is used to add all these variables into this SSE as okay, that is sum of squared error, and the inertia method is used to find the sum of squared error. Here you can see that I found the sum of squared errors. Okay, now what I'll do is that I'll plot the sum of squared error against my range, that is 1 to 9. As you can see over here also, this range from 1 to 9, and these are sum of squared errors. I got my y and I got my x as well. So when I plot this, I can see that my elbow is getting formed, and my elbow is getting formed at number 3. So this is my suitable number of clusters that needs to be formed over here. Now this, I calculated my predicted the prediction value, that what will be the cluster, okay, if I put on this as my independent variable. So I put on the characteristics, that is the sepal length, sepal width, petal length and petal width, and I got an array which is known as y predicted. Okay, I put a variable named as y predicted. Now I labeled this y predicted as cluster and put this y cluster into my data set. So this, as you can see, the clusters have been formed here. Now my next is to find the cluster centers. Now what is actually cluster center? As you can see in this picture, the cluster center is when we got the cluster, we need to find a point where the mass, or you can say the weight of these points are located, where all the mass get concentrated. That is known as centroid. So we are interested in knowing the centroid as well. So getting back into the code, so with the help of this k-means, we can also find the cluster centers as well. So I got 3 centers for 3 different flowers, as you can see this. Now what I'll be doing is that I'll be segregating again these clusters, and the cluster of 0 I have given a variable named as df1. For 1 I have named df2, and for 3 I have named cluster 2, okay, accordingly. So I'll be creating a scatter plot wherein I'll be taking 2 variables or 2 columns, that is the sepal length and the sepal width, okay, for all the 3 different clusters. It's gonna be the same, and just the color differentiation will be there, wherein you can see that color green is given to iris setosa, color red is given to iris versicolor, and blue for the iris virginica. Okay, now coming to this important part, okay, that is the centers. So what I have done over here is that I'll be taking all the rows, okay, I'll be taking all the rows over here, and I'll be giving the first column, okay, that is this. For here I'll be taking all the rows and I'll be taking the second column. So the actually in the list, the nomenclature starts from 0. That is why it has been given like this. And what I'll be doing is that I've given the color of centroid as yellow, and marker I have given as O. Okay, label I have shown is that it should be centroid. You'll be seeing soon why is this given as. So I want to diagrammatically show this as at upper right. So that is why I have given location at 1. So when I visualize this, we can see that yes, my 3 different clusters have been formed here, and along with their centroids. Now we need to know that whether the position of the centroid is same as we calculated or not. So let's do this. My first centroid should be at 5 and 3.4 or 3.3 something. So this is, as you can see here, this shows the position of the same. Here is it, 5 and 3.4. Yes, the second goes for around 5.9 and 2.6, I guess. So it's 5.9 and 2.7. Yes, because I haven't mentioned the grid here. If I would have mentioned it, it would have been more clear. But still, I believe you are getting what I'm trying to say. The third, my cluster center position of the centroid, the x and y coordinates are, it should be around 6.8 or 6.9, and following this it should be around 3.0 or 3.1 something. So it's 6